On this question, they give us this function. They want us to differentiate it and use derivatives to find a bunch of stuff. So here I've written it down here. Let's take the derivative of this function. Bring the 4 down, minus 16x to the third, subtract 1 from the power. Bring the 2 down, plus 240x to the 1, subtract 1 from the power. That's just 0. So there's the derivative. And what do we want to do with it? We want to set it equal to 0. Why do we always set derivatives equal to 0? Well, because that's where you're going to find your maxes, your mins, your increasing, decreasing stuff. Why? Well, because when f prime is 0, that means the slope is 0. The derivative is the slope, remember? And if you think about a graph, when it goes up and goes down and stuff like that, when you want to find like a max, if you're on a roller coaster, that's where you're flat. Your slope is flat. And when you're at a min, again, you're flat, right? So when your derivative is 0, when your slope is 0, when you're flat, horizontal, that's where the maxes and mins are. And in between those is the increasing and the decreasing and the increasing again spots. So you got to find those places where the derivative is 0, where the slope is 0. So that's first. So we take the derivative, set it equal to 0. We got to solve that. How do we solve that equation? Well, what you could do is you could just take out an x. Now I know you might say, well, can't you take out 16? Yeah, you could. Whatever. I don't care. I'm just to do what's easy. This, okay, boom. And then this will be what? Plus 240. See how that's right? This times this, go back to minus 16x cubed. This times this. There we go. Now set each part equals 0. So the x alone is 0 or minus 16x squared plus 240 is 0, right? See what I did there? I set the first part to 0 and the second part. Now why? Well, because that's logical. If two things are multiplying to equal 0, either one could be 0 to make that true, right? If I told you, hey, I'm thinking of two numbers and they multiply to be 0, the first one could be 0, like 0 times 7 to be 0, or the second one could be 0, right? If either the first or second is 0, they're going to multiply to be 0. So this one's all done. So there's that answer. How do we solve this one? Will you bump that 240 over? So minus 240 divide by your minus 16. I think that's 15, isn't it? 150 and then, yeah, right. Positive 15. Okay. And then what do you do from there? You root it, but careful. Plus or minus. Don't forget, that'll be death to this problem if you forget the plus or minus. I have a dorky saying when you go up and when you put a, because people forget this so often. I have a dorky saying when you put a roof on the house, like a root on both sides. Sorry, it's a lame saying. You got to go up and down the ladder. Plus and minus is my up and down. Sorry again, it's lame. It's best I could do, but I've been saying it for years now. It's helped students. So remember when you put a root on both sides, you got to put plus or minus, or you're missing half of the truth. We can see it here real quick. If I give you x squared is 9 and you root it and you just get 3, you know that's only half the story, right? Because, yeah, 3 squared is 9, but also negative 3 squared is also 9. They're both part of the story, right? Plus and minus gives the whole truth. So you got to remember when you put a root on both sides, you got to go up and down the ladder. You got to put a new roof on your house, you'd have to go up and down the ladder, right? All right, there's my dorky saying. Hopefully that'll help you never forget. When you put a root on both sides, you got to go up and down the ladder. All right, so we get the two answers for x, and then this other may have three answers altogether. What of it? Well, now we have to put those on a number line. Oh, and actually, let's go to Desmos. What is root 15? So if I go to it, not this one, there. I did it already. Root 15, 3.87. Close enough, 3 point, well, 8729, I think it was, right? Is that what it was? 3.8729, 3.87, yeah, 29, right? Okay. So there it is. So now we got to take these to the number line. So I'm going to do a big old number line and I'm going to put all three answers, put them in their actual numerical order, meaning the negative 3.8729 comes first, then the 0, and the positive 3.8729, right? And we're breaking that number line into four sections. Four sections like that. And we're going to check a point. And it's like here at -4. I'm going to check something in the left section, check something here, like how about -1, whatever. You could do -2, -3, whatever. positive 1. I'm going to check that's something in this region. And something to the right here, like positive 4, 5, 6, 7, anything. So we're checking the four regions. There's three critical breaks creating four regions. We're checking each region. Checking what? Checking the first derivative because that's the slope, right? First derivative is slope. We want to know is the slope up or down? Graph going up or down? Negative 16x cubed plus 240x. So negative 16x cubed plus 240x. That's f prime, right? So I'm going to take the negative 4. I'm going to plug it in, plug it in. So let's plug in negative 4. Let's go to Desmos, plug in negative 4. So here we go. Negative 16. What was it? Negative 4. Negative 4 cubed plus 240. And it was negative 4. So I plugged in negative 4. What am I getting? Positive 64. Positive 64. So I go, okay, it came out positive. Oh, keep the color the same here. Came out positive 64. Well, that's the slope. Remember? The f prime is the slope. So that means slope. So the graph's going up. The graph must be going up in that section, increasing because the slope came out positive. All right, let's check the middle. Same thing. We're going to say f prime, the slope is negative 16x cubed plus 240. So take that negative 1, plug it in, plug it in. That's going to tell us the slope, first order slope. So we're going to plug a negative 1 now. So go to that negative 4, make it negative 1. And what do we get? Negative 224, negative 224, negative 224. It slopes negative. So that means the graph is going down in that section. All right, next one. Same thing, f prime. Same thing. I'm going to plug in positive 1 now. All right, so here we go. Positive 1. Get rid of that negative sign. Get rid of the next one. What do we got? 224. Again, same thing. Positive, this time positive, though. So that means the slope, graph, slope's positive, graph's going up. All right, one last one. I'm going to check plus 4. So what's f prime when you check plus 4? Oops, kind of scribbled that. Go check plus 4. Let's do it. Plus 4, plus 4, plus 4. What do I get? Negative 64. Negative 64. So that's the slope. And so that tells us the graph is going down. All right, now we have a bead on that graph. We know what that graph's doing. What do you mean? What's that graph doing? Graph's going up, graph's going down, graph's going up, graph's going down. Right. So that means what? This is a local max. Oh, and by the way, yes, this is a local max. This is negative square root of 15. Remember, that's where we got that negative 3 point whatever, the square root of plus or minus square root of 15. Right? So that's negative square root of 15. And then right here at 0, this is a local min. This is at 0, right? 0. And this critical value is a local max. It's at this, which is positive square root of 15. Okay? And so let's go. What are they asking us? They're saying, okay, where is it increasing? First off, let's go. We can go to this graph. We can say, oh, it's easy to see now. Clearly, it's increasing here, going uphill, and then it's decreasing, and it's increasing, and it's decreasing. So where is it increasing? Oh yeah, let's put this. So this is negative infinity up to negative root 15, up to 0, up to positive root 15, out to infinity. So where is it increasing? Get a little scribbly there. Where is it increasing? In this section between negative infinity, negative 15, and 0, negative root 15, and 0 and positive root 15. Increasing, increasing. And that's what we said right there. Where is it decreasing? Those other two sections. This graph is decreasing and decreasing between negative root 15 and 0 and root 15 and infinity. Okay, that's how we get those answers. Now, where does it have relative maximums? Where are the local maxes? Here, negative root 15, and here, positive root 15. max and a max, negative and positive root 15, right? Max there. And finally, minimum at 0. Is that true? Minimum 0? Yep. Minimum right there, 0. The only minimum is at 0. Good. And that's it. I think it's all the questions, right? Yeah. And here's the graph. By the way, I graphed it on Desmos just for fun. There it is. See, we got it right. That's the actual graph on the Desmos grapher. See, it's a big M, right? We got it. And by the way, this what is root 15? Remember, this is negative 3.8 or something like that. So you see how this is right about right here. Here's the max, negative 3.8, positive 3.8. There's the other max. Zero's the min, right? It's going up, it's going down, going up, going down. We got it. So the power of derivatives, we figured all that out without even seeing the graph. And it was right.